in the next few problems, we once again have a polynomial on both sides. Okay, but this time the highest exponent is not x squared, it's x to the third in this problem, and then in this one it's x to the fourth. Okay, well, at least here in Math 71 anyway, when you get in a one variable equation that's like that, okay, where the highest exponent is bigger than 2, fortunately we can use the same method that we used for quadratic equations here in this section, which is the factoring method. So in other words, you still move all the terms to one side, which is actually already done for us in these two problems because you have 0, okay, on the other side already. So the terms have already been moved to one side. Now, before we go on to the next step and say that we need to factor, because that's the second step in these problems, we need to ask ourselves, do I need to like reorder the terms at all, like I was talking about up here in these problems, and I had to have it in a certain order? Well, normally, you guys, as you guys know when we talked about factor by grouping, if it's in a certain order, and I am going to do factor by grouping right here because it's 4 terms. Remember, that's the method for 4 terms. We said that if it's in a certain order and that doesn't work, we can always just reorder it and try to do a different order. So because of that, don't worry about the order that it's in right now. We can always change it if we need to, okay, if this order doesn't work. As far as this problem over here, okay, we'll just give it a try here. Usually when you have the exponents from highest, I'm not saying this is always true, but yeah, oftentimes, and this will be an example of that here, you'll see that the highest exponent is first and then the lowest exponent is last. In other words, it goes from high to low. That's usually a good strategy to use even when the highest exponent is bigger than 2, okay, usually. And so because of that, we'll go ahead and keep that in the same order as well. Okay, so let's go ahead and try problem number 3 here first. Since that has 4 terms, again, the GCF of the whole thing is 1. We always got to consider that first. But then since it's equal to 1, we'll skip that step, and we'll go right on into the factor by grouping technique since there's 4 terms. And that would give me what here? That would give me x squared on the first group. Inside the bracket, when I factor that out, it's going to be x minus 2. In the second grouping there, the GCF actually is 1, isn't it? But remember, when you have to factor out the 1 here when you're doing factor by grouping, and you're on that step where you produce the 2 brackets, you have to factor it out even if it's 1 because you got to produce the 2 brackets somehow. So I am going to factor out the 1, but if I factor out positive 1, it's not going to give me the same bracket. But if I factor out negative 1 instead, like we talked about in the factor by grouping section, consider the negative if the positive doesn't work. Doesn't that give me the same bracket, x minus 2? Okay, and so that means that I can then move the common bracket, since those 2 brackets are exactly the same. You move it to the front. I'm sorry, I wrote down the wrong one there. I meant to say x minus 2. Move the x minus 2 to the front. Okay. Just one time like we talked about, even though there's 2 of them on the previous step, just write it once. And then we get x squared minus 1. Okay. Are we done factoring? No, actually we're not. This is one of those rare situations, like I said, where you get the 2 brackets, but one of the 2 brackets breaks down further. Okay. Isn't it true that x squared minus 1, because it's something squared minus something squared, isn't that true that that's going to break down to 2 smaller brackets here? X minus 1 and x plus 1. Okay. And so that's the reason why we have to keep going there. Okay. The x minus 2 is already prime because it has 2 terms with x to the first power in it. So that, I already knew that one was prime. I don't need to touch that anymore. But this one, because you have something squared minus something squared in your bracket there, that's what you need to look out for, you guys. When you get to the 2 brackets, a lot of times, it's still rare, but the times that you do see it, though, a lot of times it will be something squared minus something squared. So watch out for that when you get your 2 brackets. That way you can then produce your 3 brackets like you need to, okay? So we get what here? We get, when we get 3 brackets, you guys, no GCF in the front, but just 3 brackets and that's it, then that's 3 things. That's how you want to visualize that. That's 3 things being multiplied together. And so we set those 3 things that are being multiplied together, each of them equal to 0. Okay. And then we solve those equations. Okay, whatever's being multiplied together, you set each one equal to 0. There's 3 things here, so we got 3 equations. What are these 3 answers? Well, if I move over the constant numbers, -2, -1, and +1, if I move all those over to the other side, I get x equal to 2, x equal to 1, and x equal to -1. So there's my 3 answers right there. Okay. All right. And finally, here in problem D, before we flip the worksheet over, we have to, since there's a 0 on one side, and since we already agreed that we weren't going to try to reorder that, we're going to give it a shot here and see if it works. We're going to try to factor this right now. Okay. It looks like the GCF here is not 1 this time. It's 2x squared. And so let's go ahead and factor that out. That gives me what here? That gives me x squared minus 6x plus 9. Okay, and doesn't that look like the Berry method now? Okay, inside that bracket with the x squared and the x and no x at all. And so that means that continuing on with my factoring after I do the GCF, 1 times 9 is equal to 9. Okay, do my big X here that I do for the Berry method. And I need the 2 numbers to add up to -6. What 2 numbers work for that? Wouldn't that be -3 and -3? They equal 9, but they add up to -6, don't they? And so finishing off my factoring, I get this right here, x minus 3, x minus 3. Okay. Putting the -3's in there with the 1x and the 1x. All right. Now, just like in this problem up here, you guys, when you have a GCF in one of these problems, followed by 2 brackets, assuming there's a 0 on the other side, okay, we then realize that that's 3 things being multiplied together, just like we did up here. Move back up here for just a moment. Okay, so now we set each one of these 3 factors equal to 0 right here. So let me write that down. And as you can see on the 2 red ones, we're going to get the same answer because it's the same equation. In this particular case, and as with any equation that you're solving, you don't need to say the same answer twice. So we only need to solve this one once since it's the same one. It's going to give us the same answer. And we only need to list out all the different solutions. Okay, so anyway, 2x squared equal to 0. When you have just a single term with a variable in it, unlike in the last problem B up here where you had a term equal to 0 but it didn't have a variable and that was different. But when it does have a variable in it, you then realize that if you have a single term with a variable in it, the only way that that could be a solution is if x is equal to 0. That's the only thing you could plug in there that would make that true. And that always happens when you have a single term equal to 0. And then the other one, as you can see there, is x equal to 3. The other one would be that same thing as well. And so we end up with just 2 answers then on this particular problem.